To kick off my series on data science career advice, I wanted to start with answering the question, what is data science? There's a lot of different definitions out there. Some of them are helpful and some of them aren't. I'm hoping to, in this episode, give you a bunch of different examples of what data science is and a couple of examples of what it isn't. Hey everybody, welcome to the channel. My name's Mike. On this channel we talk about all things data science, from data science career advice to reviewing tools and techniques of the trade and talking about how to build a high-performing data science team. All right, so let's get right into it. I think a reasonable working definition of data science is a collection of tools and techniques that allow you to extract value out of data. And so what do I mean by that? So one of the early examples of this that I saw was the concept of market basket analysis. So for market basket analysis, you think about, study all the different baskets that get taken to the checkout counter at a grocery store, right? And you take a look and you identify which items are more likely to occur in the same basket. And if you could arrange the grocery store so that folks who typically buy one thing and then another thing can buy those things in the same aisle, you can, speed up people's experience. What you'll find when you do this is that one of the strongest correlated pairs of items is diapers and beer. Right? So what you'll find the next time you go to the grocery store, check out where the diaper aisle is and check out where the beer aisle is and see how close they are. So that's just one example. In that case, the data is receipts, right? Which grocery stores obviously have with different items on them. And the value is a store that's better organized for the customers. But some other examples are when you're perusing Netflix, right? So Netflix tends to have eerily good recommendations for you. And the way that they do that is through taking a set of data. In this case, the data is what have you watched and what have other people who are like you, what have they watched? And they use that to make a prediction about what you might like watching later, right? So in this case, the data is the watch history of all of the customers. And the value is you don't have to spend as much time searching for different things. It can give you suggestions that you might not have found before all by itself, right? One of the things that data scientists do a lot of is take what is normally pretty easily done by a human. For example, reading a piece of text and deciding if it's a positive or a negative thing and scaling that. So let's say that you wanted to get a sense of the market response to a particular product launch, right? One thing that you could do is you could get a whole legion of humans to read every tweet that somebody makes about your particular product. And if it's a popular product, there might be millions of tweets, and those humans would pretty easily be able to say this is positive or negative. But the problem is that's not very efficient. And so what data science can do is, with certain techniques, take a look at those tweets, automatically assign a yes or a no, right? We have the computer read it and make its determination. And then you can aggregate those in time and you can get a sense of how's my product doing, or maybe how's my stock going to do here in the next few minutes. And so that process of taking data and pulling out the value is at the core of what data science is. All right, so let's dive a level deeper and start to think at the high level about what are the tools and techniques that make data science different from other fields which are also related to data. I see data science as primarily built on three kind of big toolkits, right? So the first one that I think of is statistical analysis. So what's an example of statistical analysis? So a simple one is clickbait titles, right? So if you are somebody who's trying to get somebody to click through your article so that they can view the advertisements, one way to do that is to do what's called A/B testing, right? And so in A/B testing, you show a randomized sample of people two different candidate article titles that you have. And what you try to figure out is, did people click more on A than they did B? If somebody clicked 4 times on A and 5 times on B, out of, let's say, 10 times that they got to see each. It's actually pretty difficult to tell if the two are different. But if somebody clicked 5,000 times on A and 4,000 times on B, it becomes easier and easier. And so statistics is this process of giving us confidence around the assertions that we make. And statistics gives us a set of tools that allow us to understand and express our confidence around conclusions. I can be confident that the title for A is better than the title for B. The next thing that I like to think about from data science is visualization. I see visualization as taking data and expressing it in a way that people understand the value that's there, right? So an example is, the COVID-19 dashboards that are around. There's a bunch that are a lot better and some that are worse, and I'll show you an example of one that I think is pretty good. But a really good data analysis is going to give you just the information that you need to make the conclusions. So I wanted to show two COVID-19 dashboards that illustrate how important it is to properly think through visualizations and the implications of not doing so. So the first one comes from one of my favorite organizations. It's called the COVID Tracking Project. I'll link it down below. In this case, it's showing a pretty simple graphic of the US cases over time. You can see a nice periodicity in each of the days where, the lower cases typically represent the weekend, and then it picks up during the week and then kind of goes down. They've put a 7-day moving average, which smooths the line. And based on this, you can see the history of the United States. So initially we got up to, 35,000 cases a day, and then it started going down. And then as things started opening up, we're on this curve that doesn't seem to quit. So you can get a pretty good sense from this about where we've been and where we're headed. And I think the proper implication is that things are headed in the wrong direction. One of my least favorite, or one of the, I think the most misleading, is this graphic from the Georgia Department for Health. In this case, you've got a similar graphic. So instead of representing the daily cases with bars, they represent it with lines, which I think is just a little bit more awkward, but you do get to see some of the periodicity. They do have the 7-day moving average, but if you take a look at this line, they've got this projection out to today. Today's the 14th of July. And what it shows is the number of cases appear to be falling off significantly. And this has to do with a lot of different things, but one of the key things is that they only account for cases when the first illness was reported. So when the first illness happened. And what that means is people will get tested today and they'll say, hey, my illness started 2 weeks ago. It'll get put 2 weeks ago. And so they have this period that's grayed out on the chart. But because it's included, it really gives a visual indication to users who might not read the graphic very well that things are actually getting a lot better, when in fact, the trend for Georgia is, among the worst in the nation. And so thinking through exactly the story that you need to tell and designing graphics to tell the story is really important. And so if you're trying to, tell the story to somebody who's studying the spread, it might be important to show them, hey, when did the onset happen? And how are we doing? If you're informing the general public, which is the purpose seemingly of this dashboard, showing a simplified graphic that gives people a better sense of where things are headed and where we are, I think is a much more powerful technique. So the other major component of a data scientist toolkit is machine learning. And machine learning is probably one of the most misunderstood concepts in data science. And I think it's probably one of the most overhyped as well, but it is incredibly powerful. So machine learning is the process of taking a set of inputs and mapping them to a set of outputs. So that sounds super boring, but we'll make it concrete. So taking you back to the tweet analysis, that's actually an example of machine learning, right? In this case, you train a machine to understand, map the inputs, which in this case is the text, right? So words, to an output, which in this case maybe is a positive or a negative. And so the set of tools that allow you to do that mapping robustly is called machine learning. So one of the things that I find is most confused in this field is the question of what's the difference between machine learning and artificial intelligence. And what I'll say for the purpose of this video is that when most people say artificial intelligence, what they mean is machine learning. If you think about it, humans are some of the best things on the planet that take inputs and map them to outputs. So for example, if you're driving, what you're doing is taking a whole bunch of visual, audio, and other inputs. You can feel vibrations and so on and so forth, and you're translating those into a set of outputs, right? Should I turn left or should I turn right? Should I go faster or should I go slower? And while that process in itself sounds pretty straightforward because a lot of us do it all the time, it's pretty clear from the fact that we still don't have any self-driving cars that that's actually a very complicated process. And so while most people think that when they say artificial intelligence, what they mean is, hey, it just maps inputs to outputs in some flexible way. I think that there are some nuances which we can talk about in an upcoming video. Today we talked about what data science is. It's this collection of tools and techniques that allow you to extract value out of data. We talked about what data science is composed of, which, in my opinion, is a combination of statistical analysis, visualization, and machine learning. And I hope that this gave you a better idea of what data science is as a field. What do you all think data science is? Did I get it wrong? Did I define it too narrowly, too broadly? Are you a data scientist that does different things than what I talked about? Please leave a comment below and we can talk about it in an upcoming video.